Now coming to the properties for the mathematical expectation or for the means, the first one says if the probability function f of x of a random variable x is symmetrical about a point. Over here, symmetrical about a point is we are taking the function f of x. The value of a is being taken on the either side, so f of a minus x is equal to f of a plus x. Then the expectation value is equal to 0. Now, whenever we have an even function, whenever we have a probability density function f of x of a random variable, it will always fetch a even function. That is, if you have a function f of x, its value is equal to that of f of minus x, or your f of minus x is equal to that of f of x, then the expectation e of x is equal to 0. The third property is linearity, which says that if expected value a of x plus b, now a of x plus b, over here a is a constant as well as b is also constant. I can take out this a outside, so it can be written as a e of x plus expected value of a constant is always a constant, hence it is b. That is, the expected value of a x plus b is equal to a e of x plus b. The next property says that if you have sum of expected values, sum of the random values is equal to sum of all the expected values. That means the collective values, the collective expectation is equal to that of the individual expectation. Now, if I consider this, if I have expected value of variables, that is x plus y plus z plus so on till last number, this will give me separate individual value as e of x plus e of y plus e of z plus so on till e of n. How we are doing for the case of sum, the same is being followed up for the product. The expectation of the product of a number of independent random variable is equal to the product of individual expectation. Now, that means the expected value of x into y into z into so on till the last value is equal to expected value of x into expected value of y into expected value of z, so on till the last value as expected value of n. The next property says that if you have a real function f of x, now this real function expected value will always be less than or equal to that of the modulus value of the real function g of x. If we consider the function as g of x, whose values is always less than or equal to the modulus value of it. The next is that if you have two functions, one is g1 of x and another is g2 of x, where the value of your g1 of x will always lies between 0 and g2 of x, and it says that the expected value of the real value function g1 of x is always less than or equal to the expected value of g2 of x, and this value is modulus. That means when you are saying the modulus value, automatically the answer that has been obtained is a real value function or a positive function. The expected value can also be written in terms of the conditional function as the expected value of x by small x is greater than or equal to a, okay, which is equal to integral over the limits a to infinity. When you are saying greater than a, that means we are giving the limits, we are talking about limits. The limits are starting from a and it is ending till infinity, is x into fx of x into dx by integral limits a to infinity f of x into dx.